So hello, everybody. We're here to talk about some of our experiences and investigation into using Linux distribution tools for building container images. I've been talking about using Linux distribution tools for about a decade and never seen this many people, so thanks for turning up. My name's Joshua. I'm an open source software engineer in VMware's open source program office, and I work on sort of ecosystem security issues for the most part.
And I'm Nisha. I am also an open source engineer at the Open Source Program Office at VMware. I am the tech lead for containers at the Open Source Technology Center, which is the technical arm of the Open Source Program Office. It's nice to see so many people interested in this topic. I usually talk about compliance, and that means that I usually speak to only 10 people or less.
Okay, so the rough agenda for today, we'll talk a bit about the motivations and context for the work. We'll share some of the investigations we made, and then we'll try and provide some kind of actionable summary at the end.
Okay, so motivations for this talk. Why are we looking at Linux distro tools to build container images? So this started off, like I said, I work on compliance for containers. And part of that work is finding out what the software bill of materials is for a given container image and where the sources are. As it turns out, it's really difficult to reverse engineer a container image for this case. People have many creative ways of building container images, and as a result, I have seen many different types of container images come through, and doing compliance or finding the software bill of materials for these images is either difficult or impossible. So when talking with Joshua about this problem, we found that actually it overlaps with a lot of security concerns as well. So we kind of boiled down our concerns for looking at Linux distro tools into these three concerns. So like I explained, compliance is finding the software bill of materials, finding the licenses that govern the distribution of that container, and then delivering corresponding sources for those components that are installed. Security involves finding what CVEs are in the container image, and also where in the supply chain those software components came from. And the third is actually building a more formalized way of building modern apps for cloud native in a way that this isn't something that you will have to reverse engineer. You would know this right off the bat.
Okay. So before we get too far into the meat of this talk, just need to level set and make it clear that when we talk about containers, we're effectively referring to container images, and we think of them as somewhat analogous to a packaging format. They're not rich as like a lot of the packaging formats those of us that come from the distro world are used to. They're fairly loose and forgiving, and they don't contain a bunch of the rich metadata that some of us expect. They're probably most similar to a VM appliance, if any of you have worked with those.
Okay, this is yours.
So, yeah. If we think of them as a packaging format, there's a few desirable properties that we would like to preserve on packages. We really want a package to be repeatable. If we've got the metadata for a package and we try and rebuild it, we expect to be able to produce an equivalent thing. We want the package to be identifiable. We need to understand what's in it, be able to reason about the license compliance implications of its contents, and the security vulnerabilities that may or may not exist there. And we really want the contents to be recent. We don't want to be shipping old software or software that we don't really know about.
Okay, so those are the properties that we would like, as Joshua mentioned. I would like to talk about how our current practices of building containers break these desirable properties. And I'm going to use the example of a Docker file, although all the other container build tools kind of follow the same principles more or less. So for example, if you were to have a run line in your Docker file, this can use any kind of script that you want. You can pass any kind of command that you want. And these are usually non-deterministic. Once you have that installed, it's really hard to repeat this. the second one is using things like apt-get update or apt-get upgrade. What happens here is that you are updating software on the fly at a given time during build. And so the property that happens, the problem that happens with this is that if you were to use the same Docker file and build a container image 6 months later, you have no guarantee that you are installing the same software in your container image. The next one is using add or copy. This is copying a file or untarring a file system or a set of files into your container image from an external file system. There is no understanding of what these files are once the container is created and shipped, and it is very difficult to reason about what those files are because they came from an external pipeline. And then the last one I want to point out is using from in the Docker file. So Docker Hub's tags are not immutable. They are rolling tags, and they very much get updated based on whether the supplier wants to update them or not. So even if you were to pull from latest, that actually may not be latest. So all of these kind of are properties that we cannot really use if we want to make hardened, deployable, production-grade software.
And so when Nisha and I were talking about these properties and how it's difficult to maintain those properties with the existing tools, the common practices, we realized that a lot of these problems have been solved in the distro space before. The Linux distributions have been building images that preserve these properties and have these concerns for a long time. And so we wanted to do some investigation into these tools and see if we could apply them to this slightly different use case.
Oh, okay. So here's the deal with distro tools. They are historically been really difficult to understand and use. I do want to point out here about the two keynotes that you heard today. One was about making Kubernetes easy to use, and the other one was about threat modeling. These are two diametrically opposite things that you are expecting your tools to do, and this is very hard to achieve. So on the one hand, you want these to be very developer-friendly tools, such that they will not feel, it doesn't feel hard to use them. But on the other hand, you want these tools to produce the production-grade software, so software of high quality. So there are several things to balance out. One is ease of use. So the reason why Docker is so popular is because it is really easy for any app developer to become an operating system vendor. So this helps adoption, but on the other hand, you want your tools to give you all that comprehensive information in order for you to make engineering decisions about whether this artifact is okay to ship. The next one is the ecosystem that this tool exists in. Docker is popular because there are so many available components that an app developer can put together and create the app for deployment. On the other hand, it is very much difficult to reason about the trustedness of these components. And the last one is that we want the tool to be very fast to use, so developers can iterate over their software as fast as possible. What that balances against is the reliableness of the thing that they're deploying. Because you want the software to be reliable, the tools end up being slower when they're building. And so these are the three things that the tools need to balance.
Okay, so at this point, Nisha and I have been talking for a while, and we had sort of the seed of an idea. Can we use Linux distribution tools to create container images, in a more identifiable, repeatable, and with more recent contents? And so we wanted to set about actually experimenting with the tools, trying to figure out whether that was possible and how far we could get. And that's what we're going to talk about next. And the first thing we had to do was choose some tools to experiment with. And the space of available distribution tools is quite large, and we needed to constrain it for the purposes of this investigation. So we did a sort of finger in the air decision-making process based on gut feeling and experience, and picked these 4 tools. And we started out with Debian because it's this extremely reliable, long-lived project with a massive amount of software available already packaged in this system. And then we looked at some embedded tools, which is the sort of the world I come from. So we looked at BuildRoute, which is an embedded image creator, kind of designed for building Linux-based firmware, and it doesn't care about updating the software. It just assumes that you're going to replace the image when you need to create an update, which is somewhat similar to a container system. Whereas Yocto project is the other end of the spectrum. It's a distribution builder. So it has a lot more affordances for building multiple images with a shared core and kind of like product SKUs, but it has different trade-offs because of that. And then finally, we wanted to look at this system called Geeks, which is based on some functional concepts, functional distribution concepts, which are interested in repeatability and immutable operating systems, which all seem highly relevant to the container space. The disadvantage for many is that it uses scheme as its common expression language, and so parentheses are intimidating to a lot of us, but it had some very interesting properties, so we decided to go ahead and play with that some too.
Okay, so what we wanted to do was try to build different types of container images using these distro tools, and we want to evaluate them based on these 4 things. Ease of use, that it should be like fairly straightforward to use these tools. The output image size should be lesser than what is already available on Docker Hub. The amount of engineering effort it takes to actually make the container image, and the quality and the presence of a software bill of materials that help us reason about things like compliance and security vulnerabilities. So we start off with our first experiment, which is build a base OS for developing Golang applications. The first tool we looked at was Debas. Debas is actually really easy to use. It's just a wrapper around Deb Bootstrap that was written in Go. It is only supported for Debian and Debian-based operating systems like Ubuntu. So if you have an Ubuntu, if you're working with an Ubuntu operating system, it's pretty straightforward to use. The image size that got created over here was actually half of the image size that was available on Docker Hub, around 400 megabytes. The engineering effort, it was fairly straightforward to build an image using this. Debas uses something called, uses a YAML file that you feed into the system. It's pretty straightforward to make this YAML file. It looks kind of like a Docker file after, if you squint enough. And so this should be like fairly straightforward for an app developer who is used to developing with Docker files to pick up. The downfall of this, the downside of this is that the software bill of materials is not there, and there is no seamless way of getting it. I do want to caveat that with the fact that Debian is a reliable operating system, and it is fairly straightforward to use dpackage to get the sources and the software bill of materials. And there are tools available for you to do that. I maintain one of those tools, but that's a later topic. Okay, so the second one we tried was BuildRoute. BuildRoute was not that straightforward to use. There's a lot of documentation. I will not comment on the helpfulness of this documentation, but it took a long time to go through it to figure out, what exactly you can do with the help of some tutorials that went missing all of a sudden. I could not build an image for Golang development per se, because this is not supported in BuildRoute. There is support for building Golang applications, but to actually have an image with a Golang with the Go binary in it, I couldn't do that. And I saw no documentation that helped. It took a lot of effort to actually build a container image, a lot of learning, but in the end, so I actually tried this for Python as well, and it was reasonably straightforward to do it for Python. So it took a lot of learning on my part. But once I got there, getting the software bill of materials was quite easy over here. So BuildRoute has a nice option called --legal info, which gets you all of the sources and the software bill of materials in various formats.
Okay, so I was playing around with the Octo project because this is a system that I worked on for a lot of years. And through working on this system for a lot of years, I can tell you that some of my colleagues who worked on this are laughing in the front. It doesn't have so much of a learning curve as a learning cliff that you can gradually inch up. And so this is, of course, hence the sad face. One of the nice things, though, is that the image sizes that you get are pretty good. To get to that place, so you have to put a lot of engineering effort in. The reason that the Octo project is quite difficult to use is because you have to understand a lot of concepts about building operating systems in order to use it. So you have to put in that legwork and then write a lot of configuration files on top of it to generate an image. But it does generate a really nice software bill of materials. You get a full list of all of the contents and the licenses, and with a minor configuration tweak, you can get all of the license files and the sources for your image and have your full compliance footprint. So it gets a very happy face for that. And then I started looking at Geeks, which has an unfortunate sort of usability spectrum because it's got this really nice unified command line tool to drive it. But as soon as you have to step outside of the command line tool, you have to write several lines of scheme with a bunch of boilerplate that's not necessarily relevant to the container use case because that's not something the tool has paid too much attention to. It generates really large images, and part of that is Geeks comes from a high-performance computing and academic software space where having all of the localization and manual information inside the image is a good thing, but you don't want to have 400 meg of manuals in your container image. So you end up with really bloated containers in this use case. The engineering effort to get there was a bit bothersome, and sadly, you don't get an automated software bill of materials like you do with some of the embedded tools. You can find that information, but you're going to have to write some code to do it.
Okay, so we actually managed to get to where the status quo still stands. You can still make a base OS that you can develop your app on top of. And that fits with the way that we do our current development, which is choose a base OS, install your app's dependencies, and install the app. And so it works pretty well in that case. But we wanted to push the envelope a little bit and see if we can build an actual ideal container, which is just the app and all of its dependencies, just its dependencies. So we're going to take a look at that case now.
Before we can get too far into this, though, we have to talk a little bit about packaging software. So in the distribution space, you create a package, you describe effectively what's in the package and how to build and install it as part of a manifest file, effectively, and it has a paired archiving format that tells you how to tells the package manager. It has an archive format that's basically a tar file, and then the package manager can read the metadata, understand the tree of dependencies for an application, and install what is required into the operating system at runtime. And the way I've described this probably gives away, our next idea was, can we leverage the package manager to install only what's required into an image? So instead of doing this operating system up thing where we are shipping an entire operating system image in our containers, can we do an app first thing and start with the application and just install its dependencies into the container image?
Okay, so our second experiment is to make a container with just enough to run the app. So the app and all of its dependencies. And what we found is that when we get to this situation, our steep learning curve becomes steeper because each of these distros are a different ecosystem and they have different ways to express your metadata, different ways to express how you want to build, and different infrastructure to package your application. And the hard part about this is that they actually don't have much support for applications built for in the cloud native space. So things like Golang and Ruby applications are not well supported. If you are used to building with Bazel, that's not supported well. It doesn't have very good support for Java applications and so on and so forth. It's either patchy or non-existent. There are some tools that help you automate this, but again, the support is quite minimal. So for example, if you are working with Debas, there are tools to help you automate Debianizing your applications based on what language you write your applications in. The trouble here is that there is no straightforward way of installing a locally built Debian package in your container image using Debas. And the second thing is that you have to Debianize all of your dependencies, and this becomes pretty harrowing if you are developing in Node.js, for example. BuildRoute has documentation that covers the infrastructure available to package your applications based on what language and ecosystem you use. Again, steep learning curve and very difficult to reason whether this is actually supported or not. The only thing you can do here is trial and error, see which one works and which one breaks. The Yocto project has a thing called recipe tool that you can use to package your applications based on what language you're writing in. The thing is that it doesn't support all of the languages that we mentioned before that cloud native developers are used to. And GUIX has a tool called GUIX Import. Once again, no support for cloud native languages. Okay.
At this point, we'd done a bunch of packaging work, which is not the most exciting. And we'd run into a bunch of issues because the Automagic tools were not as magical as we might have hoped. So we wanted to take a step back and figure out if we could actually achieve the end goal without having to go through all the rigorous work of packaging a bunch of cloud-native software. And it turns out, as the slide indicates, that we can get a bit further with most of the tools and most of the way with another one of the tools. So for the Debian, BuildRoute, and Yocto project tools, we can start off with a minimal base operating system, install our packaged application and all of its dependencies, and get a smaller container image with less bloats and a smaller attack surface. But Geeks has this really nifty command line option called Geeks Pack. And what that does is it takes an application, gathers all of its dependencies, and packs it into some distributable format. So if you come from the HPC space where the tool started, you can do something like generate a tarball with relocatable binaries so you can run Postgres on any Linux system with a libc, regardless of whether it's got Postgres and all of its dependencies installed, and regardless of whether you're root or anything like that. And they actually do have an output format for generating OCI v1 compatible container images. So I was able to generate a Postgres container image that was a few hundred megabytes, so probably a little bit on the large side, but this is all the manual bloat and localization and things that we discussed earlier. But I do just have in this container image Postgres, all of its runtime dependencies, and nothing else. So I'm not shipping most of an operating system just to run my database server, which is kind of the point of containers. So at this time, we've done a bunch of investigation. We've explored several tools, and we're coming here to talk about it. And we wanted to kind of provide some kind of summary and hopefully actionable learnings for those of you that have listened to us talk. So I'll hand you over to Nisha for that.
Okay, so I suppose the big takeaway from our talk is that we're partway there, but we're not all the way there. The tools that we have talked about come from the perspective of distro, and usually that comes from the perspective of enabling this distro on different types of hardware. And what needs to happen is there needs to be some kind of switch where we understand that there's a homogeneous hardware that we are enabling or that's already enabled from us, and to actually work from the app developer side. There are actually projects that are working on this. So Fedora is trying to reduce the size of their images for container use. So is Debian. And there are compelling reasons to help these folks. And you can help them because they're all open source projects. You can submit tweaks to the documentation so they become more easy for an app developer to pick up and use. You can submit tests in pull requests so they work for the container use case. And you can submit use cases from the app developer side, because these use cases are not necessarily visible from the distro side because they're just looking at hardware. Okay, so actionable learnings, things you can do right now in your organization. Introspect your containers to see what is installed in them. There are several tools that help you do this. Dive helps you figure out the layout of your container image, such as all the layers that are in it, and what files they might hold. Container diff is a tool that helps you figure out the difference between in the files for each of your container builds. And Turn is the tool that I mentioned before. That's the tool that I maintain. You can use it to get a software bill of materials and sources for known operating systems like Debian. Okay, and you can get halfway there with some of the tools that we've talked about. Debas, as I've said, is really straightforward to use and easy to pick up for any naive developer, naive as far as operating systems are concerned. So you can use Debas to make the base OS and the development tools that you need, or the base OS and the runtime dependencies that you need, and use that base OS when you're deploying your software, because at least you know the software bill of materials for your base OS, so you have certainty of what exactly you're shipping. Geeks has a lot of potential in creating container images that are just enough with the app and the dependencies, but you need to write a lot of glue code in order for it to get there. It's kind of like it's almost there, but it needs this last mile. So as Joshua said, the container has a bunch of manuals and software bill of materials and metadata that you don't necessarily need in the container image, but it is there, so you can, when you're pushing your container image, you can push all of those artifacts along with it as well, so that information is not lost. You can also upstream all these changes to Geeks, so the user experience is more seamless. Okay, and here are some resources for you to read if you are so inclined. There's the Debas GitHub repo, there's Debian packaging manual, there's the BuildRoute manual, and the Geeks manual, and the Yocto Project Mega manual, which I did not look at. You can talk to Joshua about that. And we also have our lab notebook if you want to take a look at and see how we got to the results that we did, and help us figure this out better. So that's there. And with that, I want to say thank you for coming to our talk.
Thanks. Yep. We have got a couple of minutes if anyone wants to ask any questions.
So in comparison to like a Docker multi-stage node, what's the payout in terms of the size of the images, something like that?
Repeat the question for the recording.
So let me repeat the question. You asked what is the comparison between the images that we create here versus what you get from Docker Hub as far as build stages are concerned?
Well, as far as building your app in Docker multi-stage build.
Okay. So the image that we were working on, which was just the base OS plus the Golang image, it's actually quite smaller than the Golang image that you get from Docker Hub. So if you were using multi-stage builds and you were using from Golang, that image you get is much larger. Like the image that I created was half the size. The other thing about it is that when you're using Docker multi-stage builds, your build stage disappears. So that breaks your build repeatability. But if you were using something that you know for sure what is installed in it, then that is not something that you care about because you already know what's in it. So does that answer your question? Okay.
Do you consider, for example, tricking app or other package managers to install it for different systems and then aren't that thing and then just come that image?
Yes. We considered that. We wanted to try and look at what was available out of the box. And so that's what we focused on for this talk. But yes, we've done that kind of trickery in the past. We just want to see. It feels like a lot of work for compared to Docker files, and that's really the baseline we had. We wanted something that was closer to Docker files usability. Thanks.
What was the workflow with all of these tools? Like, were you running this inside a Docker file or outside and outputting an OCI image? Like, I guess, how does that compare or add to the
Yeah, so what's the workflow for most of these tools? It varies a lot by tool. So most of them, you run them on the host operating system. You use, super user privileges. You feed it some configuration files, and it generates an output artifact. The only one, TechProject gets special extra mention there because it doesn't require any super user privileges. It does it all with a system called sudo, which enables you to create files with root ownership and things like that without having to be root to run them. Does that answer your question?
So,
well, I guess how do you get the actual OCI image? Like, so if you're not using a Docker file, Docker to build these, what was the workflow to actually get these?
oh, okay, yeah. So some of these tools actually have that built in where you can make a Docker compatible image, and you can use Docker import to make that image in the first place. And I suppose you can use BuildRoute or Podman to do the same thing, which is, kind of like Docker import or Docker load this tarball, and you create your base image. And then what you do with that is you push it to, if you were working internally, you push it to an internal registry. You can use Hopper for that, or you push it to Docker Hub on your repo. So kind of does that make sense? Yeah, so some of them do that, some of them don't, and that's part of the work that we need to do. So for example, Geeks makes a container image format, like with the manifest and the one layer. The thing is that one layer contains everything. Geeks has something that it's called a store. The whole store goes into the container image. So there's work that needs to happen in order to actually strip out just the root OS that you need and carry around the store with that in some fashion through CI/CD. So yeah, it's kind of patchy in that sense.
Okay, I think we're done.
Yay.
So thank you very much for your attention.
Thank you.